and welcome back to Activity 33. Today we are going to talk about Lesson 33.2. Again, the notes are not from your book, but are linked in Google Classroom, or you can take them in a notebook. All you will need today is a pencil. Now, as a warm-up, name the three-dimensional figures shown in the two pictures provided. Hopefully, you named them correctly. The first one is an example of a cylinder, while our second is an example of a cone. And these two are going to be the focus of our notes today. Now, with a cylinder, we have two circular bases, one on the top and one on the bottom. And the height is considered the perpendicular distance from the base to the base. Must be straight, not slanted. So notice we would call this a right cylinder to the right. Otherwise, sometimes it's very rare, but sometimes you see like what we call an oblique cylinder. And think about if you have like stacked a bunch of quarters on top of each other and they started to slant, that's an example of like an oblique cylinder. And when they say the distance between the bases has to be perpendicular, this would be considered the height. Now, we rarely deal with oblique. We usually deal with right cylinders. You'll see that sometimes stated in a problem. And again, that would be the example of a right. We have still a radius measure of those circles, the overall height, and again, the axis there. And a right one is the same thing as the height because it's going from center to center, not necessarily the axis here with the oblique ones. We also have cones. Cones are special because they have one base, and similar to our pyramids, they meet at the top with a vertex. And again, we cannot have a height that is slanted. The height is always, again, where it is perpendicular, and the height and the radius intersect to form that right angle. And again, we have that one circular base. We still have a radius because of that fact. Now, when we talk about our cross sections, which we talked a lot about last lesson, if we cut the cylinder, in this case, the trunk of our tree, at a certain spot, they will create different shapes. So we want to know, how can we slice each of these to get that shape? Well, the first one, to get a circle, we would slice this parallel to the base, right? If you sliced it in this direction, you would get that circular shape of your base. Versus if you sliced it perpendicularly through here, we would be creating the rectangle. So to kind of see those two in action, if we look here at our cylinders, if we slice parallel to the base, again, we see that circular shape, versus if we slice it perpendicular to the base, we see that rectangular shape. Now, to get an oval type shape, that's when you're going to have to slice this on a curve, because you'll see the oval type shape then created. So that would be this last one. The last one would have to be on a slant to get that oval shape. Now, another way of thinking about the cylinders and that rectangular cross section, I always like to think about a can of soup. Imagine if you unrolled the soup label on that can of soup, it turns into a rectangle. So that helps me remember that that perpendicular cross section is a rectangle because we're opening up that can of soup. Now, dealing more with our cross sections, again, if we want to focus on our cross sections being parallel to the base, that's again when it is going in the same direction. So reminder, parallel means the same direction as our base. Okay, so same direction here. I'll put that as well as the base. So if we look back at our figures here, for a cone, if we are looking to create this parallel to the base, and you can either play with either one of these, here we see no matter where we slice at, whether we are slicing high or low, we're creating these circles on here. And again, we can look at that on this other one as well, because you actually have that on the plane. As we move this up and down, we see these circles created. Now they're not congruent circles, but they are circles in shape. The same is going to be said for our cylinders. As we move this slice up and down for our cylinders here, we still see this circular shape. In fact, it's going to be congruent circles when it comes to our cylinders. Again, these are going to all be the same size as we slice through here on that. So again, when we're parallel to our base, we would say that they have the shape of circles. Same as the base. Now, if we are talking about being perpendicular to our base, however, it's going to be a little bit different, because if we move this perpendicular, cutting vertically, what we're going to notice is this is going to create a rectangle throughout this, okay? And again, if we move this around, this rectangle around, we see it being always creating some shape that's a rectangle, possibly different sizes. Versus with our cones, when we slice vertically, it's going to depend. If we are through the vertex, we see a triangle. However, if we are not through the vertex, it is not a triangle. Again, when we look at the cones, maybe on this one you'll see a little bit better. When we are vertically shaped, they actually are going to start looking like resemble a trapezoid kind of, but through the vertex we see that beautiful triangular shape there. So that's kind of getting through these next pieces. If we're perpendicular through the vertex, so this one's particularly through the vertex, we know it's going to be a triangle. And if we are perpendicular to the bases in a cylinder, it is going to be a rectangle. However, when we are parallel, like we talked about up above, we're going to have circles. Now, specifically, when we are cutting in different spots, in a cylinder, they're going to be congruent circles. So they're all the same size and shape. However, in our cones, our circles are not necessarily the same size when we cut them. So they're still all circles, but we would just call them similar, not congruent circles. And again, that's because they have different sizes. Okay. Now, if we were looking to find the area of the cross section when it's parallel to the base for either a cylinder or a cone, remember that would be dealing with a circle. So if you were looking for the area of the base, you would actually be finding the area of a circle, which from earlier in this unit from part 1, we know is pi r squared. Thanks everyone for watching, and we will work more with this.